According to National Electrical Code Section 620.51, means shall be provided to disconnect the main power supply to the equipment. This disconnecting means must be capable of being locked in the open position, suitable for breaking the full load current plus 25%, and marked as the disconnecting means for the escalator. The NEC does not specify the exact location of the disconnecting means as long as it meets these requirements. Therefore, a motor control center, or MCC, disconnect that is already in place and meets the requirements is sufficient. It needs to be lockable, sized correctly, and marked as the disconnecting means for the escalator. Further considerations include that the disconnecting means should be readily accessible to authorized personnel. It is good practice to have a disconnect switch in the pit near the controller for maintenance and emergency purposes. However, this is not explicitly required by the NEC. Based on the NEC, an existing MCC disconnect is sufficient as the disconnecting means for the replacement escalators. However, it is recommended to consider adding a disconnect switch in the pit for convenience and safety. Let's delve into the details of each of these requirements to fully understand the implications. Firstly, the requirement for being capable of being locked in the open position is crucial for safety. This ensures that during maintenance or repair work, the escalator can be positively isolated from the power supply, preventing accidental startup and potential injury. This lockable feature must be robust and reliable, employing a mechanism that can securely hold the disconnecting means in the open position, typically through the use of a padlock or similar locking device. Secondly, the disconnecting means must be suitable for breaking the full load current plus 25%. This requirement addresses the need to safely interrupt the current flow under various operating conditions, including situations where the escalator motor is under heavy load or experiencing a transient surge in current. The additional 25% margin provides a safety factor to account for these potential overloads and ensures that the disconnecting means can effectively break the circuit without damage or failure. This sizing requirement necessitates careful calculation of the escalator motor's full load current, taking into account the motor's horsepower rating, voltage, and efficiency. The disconnecting means must then be selected with an ampere rating that exceeds this calculated value by at least 25%. Thirdly, the disconnecting means must be marked as the disconnecting means for the escalator. This marking serves to clearly identify the purpose of the disconnect and ensure that it is readily recognizable to authorized personnel. The marking should be permanent, legible, and located in close proximity to the disconnecting means. It should clearly state that the disconnect is intended for the escalator, providing a clear and unambiguous indication of its function. Considering the location of the disconnecting means, the NEC provides flexibility, not mandating a specific location as long as the previously mentioned requirements are met. This allows for the disconnecting means to be located in a variety of locations, such as an MCC room, an electrical closet, or even within the escalator pit itself. The key consideration is accessibility. The disconnecting means must be readily accessible to authorized personnel, meaning that it should be located in a place that is easily reached and not obstructed by other equipment or structures. In the case where an MCC disconnect already exists and meets all of the requirements, it can be considered sufficient for the escalator disconnecting means. This can save time and money by avoiding the need to install an additional disconnect. However, it is important to verify that the existing MCC disconnect is indeed lockable, properly sized, and clearly marked. If any of these requirements are not met, then an additional disconnect will need to be installed. The recommendation to add a disconnect switch in the pit for convenience and safety is based on practical considerations. While not strictly required by the NEC, having a disconnect readily available in the pit can greatly simplify maintenance and emergency procedures. It eliminates the need for maintenance personnel to travel to a remote location to disconnect the power, saving time and reducing the risk of accidents. In emergency situations, a disconnect in the pit allows for quick and easy shutdown of the escalator, potentially preventing further damage or injury. The decision to install a disconnect in the pit should be based on a careful assessment of the specific installation and the needs of the facility. Factors to consider include the frequency of maintenance, the potential for emergencies, and the availability of qualified personnel. If the escalator is located in a high-traffic area or is subject to frequent maintenance, then a disconnect in the pit is likely to be a worthwhile investment. Ultimately, the goal is to ensure the safety of personnel and the reliable operation of the escalator. By carefully considering all of the relevant factors and adhering to the requirements of the NEC, it is possible to design and install an escalator disconnecting means that meets these objectives. To further elaborate, let's consider the process of calculating the full load current of the escalator motor. This calculation is essential for selecting a disconnecting means that is properly sized to handle the motor's current requirements. The full load current can be determined using the following formula. Full load current equals horsepower x 746/voltage x efficiency x power factor, where horsepower is the rated horsepower of the motor, 746 is the conversion factor from horsepower to watts, voltage is the rated voltage of the motor, efficiency is the motor's efficiency expressed as a decimal, and power factor is the motor's power factor expressed as a decimal. Once the full load current is calculated, it must be increased by 25% to determine the minimum ampere rating of the disconnecting means. For example, if the full load current of the escalator motor is calculated to be 20 amps, then the disconnecting means must have an ampere rating of at least 25 amps. 20 amps x 1.25 equals 25 amps. It is always advisable to select a disconnecting means with a slightly higher ampere rating than the minimum required to provide an additional margin of safety and account for potential future increases in load. In addition to the ampere rating, the disconnecting means must also have a voltage rating that is equal to or greater than the rated voltage of the motor. This ensures that the disconnect can safely interrupt the voltage of the circuit without damage or failure. The type of disconnecting means used for an escalator can vary depending on the specific installation and the preferences of the designer. Some common types of disconnecting means include fused disconnect switches, non-fused disconnect switches, and circuit breakers. Fused disconnect switches provide both disconnecting and overcurrent protection, while non-fused disconnect switches provide only disconnecting means. Circuit breakers can also be used as disconnecting means, and they offer the advantage of being resettable after an overcurrent event. When selecting a disconnecting means, it is important to consider the environmental conditions in which it will be installed. If the disconnect is located in a damp or corrosive environment, then it must be rated for those conditions. NEMA ratings provide a standardized way to classify the environmental protection provided by electrical enclosures. For example, a NEMA 4 enclosure is designed to be watertight and dust-tight, making it suitable for use in outdoor or washdown environments. In addition to the NEC requirements, there may also be local codes or regulations that govern the installation of escalator disconnecting means. It is important to consult with the local authorities to ensure that the installation complies with all applicable codes and regulations. Proper installation of the disconnecting means is critical to ensure its safe and reliable operation. The disconnect must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. The wiring connections must be tight and secure, and the disconnect must be properly grounded. Regular maintenance of the disconnecting means is also essential to ensure its continued reliability. The disconnect should be inspected periodically for signs of damage or wear, and any necessary repairs or replacement should be made promptly. The disconnecting means should also be tested periodically to verify that it is functioning properly. This testing can be performed by a qualified electrician using appropriate test equipment. In conclusion, understanding and adhering to the NEC requirements for escalator disconnecting means is essential for ensuring the safety of personnel and the reliable operation of the escalator. By carefully considering all of the relevant factors and following best practices, it is possible to design and install an escalator disconnecting means that meets these objectives. Furthermore, let's explore the practical implications of having a readily accessible disconnect switch in the escalator pit. While the NEC doesn't explicitly mandate it, the advantages it offers during maintenance and emergency situations are considerable. Imagine a scenario where a technician needs to perform routine maintenance on the escalator's drive system. Without a disconnect switch in the pit, they would have to locate the main disconnect, potentially in a remote MCC room, and coordinate with another person to ensure the escalator remains energized throughout the procedure. This not only adds time to the task but also introduces potential communication errors. With a disconnect switch conveniently located in the pit, the technician can quickly and safely de-energize the escalator themselves, minimizing downtime and streamlining the maintenance process. The benefits are even more pronounced during emergencies. Consider a situation where a passenger's clothing gets caught in the escalator mechanism. Every second counts in such a scenario, and a readily accessible disconnect switch allows for immediate shutdown of the escalator, potentially preventing serious injury. The time saved by having a disconnect in the pit can be crucial in mitigating the severity of the incident. Moreover, a disconnect in the pit can facilitate troubleshooting and diagnostics. If the escalator malfunctions, a technician can quickly isolate the power supply and begin investigating the problem without having to navigate to a remote disconnect location. This can significantly reduce the time required to identify and resolve the issue, minimizing disruption to passengers. From a safety perspective, a disconnect in the pit provides an additional layer of protection for maintenance personnel and emergency responders. It allows them to quickly de-energize the escalator in a controlled manner, reducing the risk of electrical shock or other hazards. The presence of a disconnect also serves as a visual reminder of the potential electrical hazards associated with the escalator, promoting a culture of safety awareness. While the initial cost of installing a disconnect switch in the pit may seem like an additional expense, the long-term benefits in terms of increased efficiency, improved safety, and reduced downtime can easily justify the investment. It's a proactive measure that demonstrates a commitment to safety and operational excellence. In addition to the practical advantages, having a disconnect in the pit can also enhance compliance with industry best practices. Many organizations and regulatory bodies recommend or even require the presence of a local disconnect for escalators, recognizing the importance of easy access to power shut-off in emergency situations. By implementing this best practice, facilities can demonstrate their commitment to safety and reduce the risk of liability. Furthermore, the location of the disconnect switch in the pit should be carefully considered to ensure its accessibility and visibility. It should be mounted in a location that is free from obstructions and clearly marked with appropriate signage. The disconnect switch should also be of a robust design, capable of withstanding the harsh environmental conditions often found in escalator pits such as dust, moisture, and vibration. Regular inspection and maintenance of the disconnect switch are essential to ensure its continued reliability. The switch should be checked for signs of damage or corrosion, and any necessary repairs or replacements should be made promptly. The switch should also be tested periodically to verify that it is functioning properly and that it can effectively interrupt the power supply to the escalator. In conclusion, while the NEC may not explicitly require a disconnect switch in the escalator pit, the practical advantages and safety benefits it offers make it a highly recommended addition. It's a small investment that can yield significant returns in terms of increased efficiency, improved safety, and reduced downtime. By carefully considering all of the relevant factors and following best practices, facilities can ensure that their escalators are equipped with a disconnecting means that meets the highest standards of safety and reliability. Let's dive even deeper into the specifics of marking the disconnecting means for an escalator. The importance of clear and unambiguous labeling cannot be overstated, as it is crucial for ensuring that authorized personnel can quickly and easily identify the correct disconnect in emergency situations or during maintenance procedures. The marking should be permanent, legible, and located in close proximity to the disconnecting means. Ideally, the marking should be directly affixed to the disconnect switch enclosure, using a durable label or engraving. The marking should clearly state that the disconnect is intended for the escalator, using unambiguous language such as escalator disconnect or escalator power shut-off. The use of abbreviations or technical jargon should be avoided, as it may not be readily understood by all personnel. In addition to the descriptive text, the marking should also include the escalator's identification number or name, if applicable. This can help to further clarify the disconnect's purpose and prevent confusion if there are multiple escalators in the vicinity. The size and font of the marking should be large enough to be easily read from a distance, even in dimly lit conditions. The use of contrasting colors can also enhance visibility, such as white lettering on a dark background or vice versa. The marking should be resistant to fading, abrasion, and other environmental factors that could degrade its legibility over time. The material used for the marking should be durable and suitable for the intended environment. For example, if the disconnect is located in a damp or corrosive environment, the marking should be made of a material that is resistant to moisture and chemicals. The marking should be inspected periodically to ensure that it remains legible and in good condition. If the marking becomes damaged or faded, it should be replaced promptly. In addition to the marking on the disconnect switch enclosure, it is also a good practice to provide additional signage in the vicinity of the escalator to indicate the location of the disconnecting means. This signage can be particularly helpful in large or complex facilities where the disconnect may not be immediately obvious. The signage should be strategically placed in areas where it is likely to be seen by authorized personnel, such as near the escalator entrance, in the escalator pit, or in the electrical room. The signage should include a clear and concise message such as escalator disconnect located here or emergency power shut off for escalator. The signage should also include an arrow or other visual cue to indicate the direction of the disconnect. The size and font of the signage should be large enough to be easily read from a distance, and the signage should be resistant to fading and other environmental factors. The signage should be inspected periodically to ensure that it remains legible and in good condition. If the signage becomes damaged or faded, it should be replaced promptly. By implementing a comprehensive marking and signage strategy, facilities can ensure that the disconnecting means for their escalators is easily identifiable and accessible to authorized personnel. This can significantly improve safety and reduce the risk of accidents in emergency situations or during maintenance procedures. The goal is to make it as easy as possible for anyone who needs to de-energize the escalator to quickly and accurately locate the correct disconnect. This requires a combination of clear and unambiguous labeling, strategic placement of signage, and regular inspection and maintenance of the markings and signage. Furthermore, consider the importance of training personnel on the location and operation of the escalator disconnecting means. Even with clear markings and signage, it is essential to ensure that authorized personnel are familiar with the location of the disconnect and how to operate it in an emergency. Training should be provided to all personnel who may be required to operate the disconnect, including maintenance technicians, emergency responders, and security personnel. The training should cover the following topics: the location of the disconnecting means, the purpose of the disconnecting means, the proper procedure for operating the disconnecting means, the potential hazards associated with operating the disconnecting means, the importance of following safety procedures, and the location of emergency contact information. Training should be conducted by a qualified instructor and should include both classroom instruction and hands-on practice. Trainees should be given the opportunity to operate the disconnecting means under simulated emergency conditions to ensure that they are comfortable and confident in their ability to do so in a real emergency. The training should be repeated periodically to ensure that personnel retain their knowledge and skills. Refresher training should also be provided whenever there are changes to the location or operation of the disconnecting means. In addition to formal training, it is also important to provide ongoing reminders and reinforcement of the importance of safety and the proper use of the disconnecting means. This can be done through safety meetings, posters, and other communication channels. Personnel should be encouraged to report any safety concerns or issues related to the disconnecting means. By investing in comprehensive training and ongoing communication, facilities can ensure that the personnel are well prepared to respond to emergencies and to operate the escalator disconnecting means safely and effectively. This can significantly reduce the risk of accidents and injuries and improve the overall safety of the facility. The goal is to create a culture of safety awareness in which all personnel understand the importance of the disconnecting means and are committed to using it properly. This requires a sustained effort to educate, train, and remind personnel about the importance of safety and the proper use of the disconnecting means.